Hello and welcome back to the SHA1 Performance Quest episode 5.5. I know last time I said goodbye, I basically promised to do the Golang implementation. This is why this episode is just on mark 0.5 instead of 6. I realized that moving on that swiftly is probably a bad idea because our code is still in quite a bad state. I mean, it's not only about performance, it's also and always about maintainability. Therefore, I don't want to imply that just moving on to the next hot topic is the right thing to do in all cases. No, instead we should clean it up. So what can we do here? I think first of all, I'd like to move all the extra utility types like fixed buffer and these loose functions there into their own module. That way we have a clearer view onto the actual SHA1 implementation. So I create a new utils.rs module where I throw everything in. That's what I did until I stumbled upon the toHex method, which seems to create a new output string from a input byte array that is hexlified. But it does that by taking the input, iterating it, and converting each byte into a hexadecimal string of 2 bytes, which is then appended to the output. So there's a lot of heap allocations, and I thought, man, there must be a better way to do this. I mean, sure, you can easily implement this yourself there, but I thought the standard library would have something like it. Serialized hex seemed to be something that could work. It implements a trait, and yeah, that's kind of where I stopped, even though I was quite confident that they have implemented it for our U8 array that comes in there, or slice basically. But I didn't want to find out because the method that we see there is absolutely non-critical. It's just called when taking the final SHA result as a hexadecimal, so no biggie. The first time I ran the compiler, I realized that the newly created utils module is actually private to our parent now. This is somewhat, totally acceptable, but it's somewhat unexpected because I was always thinking that parents can access their children, but that's not true. And it's the right thing to do, obviously. So basically all I had to do is make the fields and structures that I wanted to access from the parent module public. A few pubs later, the compiler agreed to compile the program for me, just spitting out a few warnings that are easy to fix. Constants should be uppercase, fair enough, and there is an incorrectly named function, which obviously isn't going to stop anybody. Well, now that the program runs fine without any compiler warnings, I'm quite happy to move on finally to episode 6 of the SHA1 Performance Quest. Thanks for watching and hope to see you next time.